In fact, if you look at the 802.11 standards, and if you read it carefully, you will see more than one security mechanism for encryption. You will see many of those. You will first see the wired equivalent privacy, WEP, designed in the original protocol in 1997. That uses an algorithm, an encryption algorithm, which is called RC4. But then you'll also see some other mechanisms. If you read the Wi-Fi Alliance literature, you'll see there is something called Wi-Fi Protected Access, WPA. This is also called WPA v1 because there is a v2. This mechanism was based on the 802.11i amendment that was released in 2004, but they took the draft from 2002 because WEP was already seen as so weak that we need something urgently at the industry level to replace WEP. So that builds on WEP and actually adds a few more things like the message integrity check, like MIC. It also encrypts and sends inside the encrypted payload the source MAC address, also a timestamp. And that allows you to identify on the receiving end if you are reading the frame from the real sender or if somebody is trying to spoof somebody's frame and replay it. That makes security a bit more efficient. It also has a better encryption mechanism. It still uses what we call RC4, but it also uses something that WEP also has, which is called the initialization vector, which is a value, a random value you put in your frame. And that random value with WPA v1 is longer. So that makes the encryption kind of like WEP, but stronger than WEP. That mechanism with RC4 algorithm, but on steroid with a longer initialization vector, this timestamp, the source MAC, and the message integrity check is called Temporal Key Infrastructure Protocol, TKIP. Then when 802.11i was published in 2004, the replacement of WPA v1 was published at the Wi-Fi Alliance, and that of course had the name WPA v2. It's purely an application of 802.11i, and the encryption mechanism we use there is not RC4 anymore, it's AES CCNP. Now, if you look into the industry, you will see WPA, and that's WPA v1, and you'll see WPA v2. And many people still see them as being kind of the same because they're, after all, using the same acronym. So what is the difference? Well, WPA v1 is based on WEP type of encryption. Better because you have message integrity check, etc. So all this is what we call TKIP. And TKIP is a lot stronger than WEP, but it's using the same algorithm. And WPA v1 uses TKIP, but allows a stronger algorithm, which is described already as being AES, but we'll see that AES has a component that is called CCNP. CCNP adds to AES, which is just an algorithm, to add some more things to AES to make it even stronger. And that's what we have in WPA v2. But when WPA v1 was released, the notion of AES was already present, so it's there in the certification, but all things we added to AES to make it even stronger were not there yet. So WPA v1 does not describe them. So if you implement WPA v1, you may be implementing TKIP properly, you may be implementing AES, and maybe with CCNP with these add-ons, and maybe not. No guarantee there. In WPA v2, we have to use AES. We do not use WEP anymore. We do not use TKIP. We use AES. And we use CCNP on top to make it even secure. But there is this notion of being backward compatible with other mechanisms. So although TKIP is not the mechanism of choice, it is still allowed for backward compatibility with this older WPA v1. But the natural mechanism is AES CCNP. In both cases, with WPA v1 and WPA v2, you can use in small networks this personal security, which is pre-shared key, basically a key for everybody. Or you can use in larger enterprise type of environments, 802.1x/EAP, to do the individual user authentication, derive a PMK, and use that PMK to derive the encryption key unique to each user. So that is if you read everything in 802.11. But now, if you take that list again and you look at what you can use out of this, we say, well, you don't want to use WEP, because there are tools everywhere on the internet that allows you to crack WEP within seconds. So there is no way a WEP network can resist any attack today. So that's legacy. If you think about security, you just do not want to use WEP. That's one thing. But the other thing is that WPA v1 itself was released by the Wi-Fi Alliance in days where WEP was weak and we were in need of an urgent solution to be better than WEP. That's what WPA v1 was about. Then 802.11i was published in 2004, and from 802.11i, the Wi-Fi Alliance derived WPA-v2. So WPA-v1 did its job, that was to be a temporary mechanism to replace WEP until we had something better. And today we do. We have WPA-v2. So in fact, WPA-v1 itself is going away. As a matter of fact, the Wi-Fi Alliance says, you should not use TKIP anymore. That is a sort of WEP on steroid, but still WEP, so that's a temporary replacement. That should not be used in normal networks anymore. You should use AES CCNP. So of course, if you remove TKIP, well, basically you remove WPA-v1. So if you look again, you say, all of the mechanisms I can see, the only ones really that I can and should use is WPA-v2. That is to say the certification of 802.11i using maybe pre-shared key in small networks or individual user authentication in enterprise networks with only one security, AES CCNP. And if you use that, your network is encrypted securely, and it's very difficult to crack. If you use any of the others, the gray ones, well, you're implementing some legacy mechanisms that should not be used, and your network may be attacked, and you may be eavesdropped.